to circles. The items we're going to be talking about are tangent, point of tangency, the relationship between a tangent and a radius, something called a secant, and then tangents from a common point. So first off, a tangent line is simply a line, now that does mean that it goes on infinitely in either direction, notice the arrows, right, that touches a circle at exactly one point, meaning it touches the actual outer part of the circle. And that means it does not cross inside the circle at all. It does also mean, and a big consequence of this, is that the radius, that is this line right here, that touches that point of tangency, that is this thing here as labeled, forms a right angle. So it's very important to remember that this is a right angle where the tangent line and the radius that touches that tangent line meet. A secant line, well, if it can touch at one point, then it can touch at 2 points, and that line is called a secant line. Simply put, a secant line crosses through the circle. Please note, a secant line does also form a chord, because if you look at this, they're part of that secant line, that segment is indeed a chord. The last thing we need to talk about are tangent lines from a common point. So if you've got a point external to the circle, right here, right, we'll call that point A, and you've got a line that is tangent to the circle from that point, and let's say that's tangent at point B, and we have another line, second line, so such that it's tangent at point C, then we do know if we were to draw the radii in, so let's call this circle O, that's a popular name for a circle, we know that that and that right there would form right angles. Now if you look carefully, we've also got a, well, four-sided figure. It looks a lot like a kite, but let's just make sure here, because if we were to connect O and A, then what do we get? Not one, but two right triangles. They have this side in common, that'd be the hypotenuse, opposite the 90 degree, and they also have the radius in common, which would be the same length, which means then that these two triangles are congruent. So what this means in the grander scheme of things is that the two tangent lines themselves, that is AB and AC, are also congruent. So if you have two tangent lines from a common point, that is a point external to the circle, then those two lines are congruent. This is kind of a very important feature, just to illustrate that one more time. So if I have a circle and I know that I've got a tangent line from some point outside the circle, whoops, let's try to draw that so it actually is tangent. Let's go there. So like there, let's say that that's tangent and that's tangent, and because they're coming from the same point, we know that they're both tangent, then we know that they're congruent to each other. It's going to be a very important consequence there. So just to sum up, we've talked about what it is to be tangent to a circle, that is a line that touches only once. The point of tangency is where it touches. Key thing, relationship between a tangent and a radius, that is the radius that it hits the tangent at the point of tangency is perpendicular to it. A secant is a line that crosses the circle twice, does create a chord, and tangents from a common point. So those two tangents from that common point are, big thing, congruent.